So the flow of electrons will contribute for your current, right? So based on this, there are two types of current. One is called as drift current. Take it down, drift current, right? What happens actually because of the current? The electrons are moving and therefore the current is flowing, right? So drift current is given by data. Current which exists in the conductors, current which exists in the conductors, current which exists in the conductors due to the drifting of electrons. Current which exists in the conductors due to the drifting of electrons is called as drift current. Drifting is nothing but movement. Okay, this is the case of your conductors, right? In conductors, the flow of electrons or the current is due to the drift of your electrons. That is why it is called as drift current. Is it clear? Right. The next is about displacement current. Displacement current. This is normally in the case of dielectrics. You know, displacement current is normally in the case of dielectrics. In dielectrics, you can say that the flow of electric charges in dielectrics, the flow of electric charges in dielectrics, the flow of electric charges under the influence of electric field intensity, under the influence of electric field intensity is called displacement current, called as displacement current. In dielectrics, the flow of charges under the influence of electric field intensity is called as, what is that? It's called as displacement current. Okay? Right. Now we'll go for the, what is current density? Now tell me what is current density? Current density J is equal to I divided by A, or total current divided by your surface area. Okay? Now we'll find out the next one. The relation between J and I. How they arrived at this relation? How they arrived at this relation? Right. We consider a surface, yes. Consider a surface, yes. Consider the surface, yes, and current I is passing through the surface, and the current I is passing through the surface with an incremental distance of ds, right? So imagine there is a surface area here with an incremental distance of ds. Okay, imagine there is a surface here, okay, and you are going to consider a small area, so let us have it as ds. So for this, you can say that this will be your unit vector and J will be your current density, okay, and this surface is given as ds. Okay, now listen, what is ds vector? How do you denote ds vector? Ds vector is equal to ds dot an vector. ds dot an vector. We have seen this already, no? Any vector quantity can be determined by your magnitude into your normal vector. What is the normal vector to the surface? What is the normal vector to the surface? An. So ds vector is equal to ds into an vector. Okay. Similarly, j is equal to j dot an vector. J dot an vector. So what is vi? Vi is equal to j dot ds, right? So I is equal to integral of j dot ds. I is equal to di is this, so I is equal to integral of j dot ds. Okay? Clear? And we can say that the angle between j and I is never equal to 90 degree. It again depends upon your dot product, right? So j dot ds is not 90 degree, it is again depending upon your dot product. It means that the cos of the angle that is formed between the current and your current density. Is it clear? Now, the angle between J and ds, the angle between J and ds is not 90 degree. It's not 90 degree, and it depends upon the dot product of J dot ds. Dot product of J dot ds. Okay. Here, now we see the relation between J and rho v. What is J, ma? What is J? Current density. What is rho v? Volume charge density. Rho v is called as volume charge density. So let us see what is the relation. Take it out. Relation between J and rho v. Relation between J and rho v. So imagine the charge particles are here, right? And rho v is the charge density here, right? Rho v is the charge density, and imagine this is a surface, yes. Surface, yes. But the charge particles here. So because of this charge particles, let us understand that rho v will be a volume charge density. Okay, take it out. Finish. Let us imagine a surface is moved along your x-axis, right? Initially it was near the origin. Now what I have done here, can you imagine? This volume is moved along your x direction. It is moved along your x direction. And what is the distance it is moved? It is moved a distance of del x. It has moved a distance of del x. Okay. So using this we are going to find out what will be the relation between J and rho v. Again. Finish the diagram. Be fast. Draw the diagram alone and do the explanation. Finish. Don't write the expressions. Finish now. Yes, now sir. So, diagram finish. Draw the diagram. Right, now listen. So what is del V from the structure? What is del V? It is moved toward distance of del x. What is del V? Del V is the total volume. Volume is del S into del L. Right? Del S into del L. So del V is equal to del S into del L. Del Q. Right? Charge, volume charge density is equal to del Q divided by del V. Sorry, dV. Right? So del Q is equal to what you get, right? Rho V into dV, or you can have it as equal del V. Clear? How will I get this relation, mark? Charge density is equal, volume charge density is equal to del Q divided by del V. Is it not? Rho V, volume charge density is equal to del Q divided by del V. So what is del Q? Del Q is equal to rho V into del V. Clear? What we have got for del V here? Del V is equal to S, del S into del L. So I am going to substitute that here. So del Q is equal to rho V into del V can be written as del S into del L. So clear to this? Okay? Following? Yes or no? Could I repeat this? No. Now listen. What is del I? Del I is equal to del Q divided by del V. Rate of change of charges. So Q divided by D. Del I is equal to del Q can be replaced by rho V into del S into del L divided by del D. What is the distance it has moved? Del S can be written as del X. It has moved to a distance of del X. Del X by del D is nothing but the velocity, right? Rate of change of displacement is called as velocity. So it is given by del X by del T can also be written as Vx. Okay? So here we have del I is equal to rho V into del X into del X. Okay? So we have del I is equal to J. What is J? Already we have got this relation. Del I is equal to J dot ds. Del I is equal to J dot ds. So from that J is equal to what you are infer from that? Go through that expression. J is equal to rho V into del X. Relate the two expressions, ma. Relate the last two expressions. What do you get? Relate the last two expressions. J is equal to rho V into V. This is the relation of J and rho. Can you all understand what I have done? Once again, I am repeating. What is del V? Volume, that is equal to del S into del L. Surface area into L is equal to their volume. Q is equal to del V divided into del Q. Sorry, del V into rho V into del V. So in the place of del V, I am going to substitute this. Okay. So I is equal to dq del Q by del D. Del Q is taken and it is replaced here. Del L by del T can be replaced by del X by dt because it is moved by distance of del X. Okay. So what is rate of change of displacement? It is given by Vx. Okay. So our velocity. So del I is equal to what is that? Rho into del S into Vx. So from that we arrive at this relation. Clear? Take it up. Fast. Volume charge density. Okay. So they are asking you have to derive this. Okay. Can we go for the next problem? Figure out. In the cylindrical coordinate system. Should I wait? Yes. Take it out. Already completed. I have to wait. The second unit we have 3 more topics. I'll be able to complete before this event. You learn this song? It's Friday. No, I it down now. In cylindrical coordinates, J is equal to, in cylindrical coordinates, J is equal to 10 e power minus 100 r A5 ampere per meter. J is equal to 10 e power minus 100 r A5 into A5 ampere per meter. Listen. Find the current. Find the current crossing through the region. Find the current crossing through the region. Find the current crossing through the region. 0.01 less than or equal to R, less than or equal to 0.02 meter. Listen carefully. Find the current crossing through the region. 0.01 less than or equal to R, less than or equal to 0.02 meter, and 0 less than or equal to Z, less than or equal to 1 meter. Right? And the intersection of this region, with phi is equal to a constant plane, and the intersection of the region with phi is equal to a constant plane. Yes, how do we solve it? You are going to tell me, how do we solve this? What is asked in the problem? What is asked in the problem?
Current passing through the region.
What is that?
Current passing through the region.
Current passing through the section. How do you find out? How do you find? What is given here? What is given here? Current density is given. How do you find out current?
J
is equal to
area. Current density in the area.
Area. So current I want. So how do I find it out?
J
I is equal to
J
into A or surface area, right? In the case of A, it is nothing but differential surface area. Okay, now. So what is that? I is equal to surface integral of, right? Okay, J dot ds. J dot surface area is given as ds. Okay, so here what will be a surface area? What will be a surface area? Let's first look at what is surface area. Variables of what is given? Your problem. R is given. Z is given. So what will be a surface area? Anybody? dr dz into the unit vector normal to that. What will be the unit? Cylindrical coordinate system. But think and answer this. First unit object. What is cylindrical coordinate system? R, phi and Z. Right? When R and Z are varying, what will be the perpendicular or the normal vector to R and D? Is it phi. So how can I write this? ds can be written as dr dot dz into a phi. Okay, now so what is dr? ds is equal to dr dz a phi. So first we find out j dot ds. J dot ds will be this into this. What is that? A5 dot A5 will become 1. Very good. Others? A5 into A5 will become 1. So the remaining terms will be coming here. What are they? 10 e power minus 100 r. Is it not? 100 into dr dz. Here. Okay. Now what is constant here? 10 e power minus 100 r is constant. So I want to find surface integral of A dot ds is equal to 10
e power minus 100 r.
10 alone is constant. What is the other terms that are going to vary? E power minus 100 r and dr ds. So 10 alone we will take it out. Integral of, right? R is varying from 0.01 to 0.02 e to the power of minus 100 r into dr, right? Integral of z values from 0 to 1, right? Into dz. That's it. See the, we have to find out the current, right? So first what we have done here, understand the steps thoroughly. Current is asked, current is equal to J dot ds. J is given in the form of problem. You have to find out ds. What are the two parameters that are varying? R and z are varying. So ds is equal to dr and dz. As per cylindrical coordinate system, what are they? R, z and phi are the three ordinates. R and z is varying means what will be the normal vector? Normal vector will become a phi. Is it clear, students? Okay, so ds is equal to dr, dz, a phi. Then we have to find out j dot ds and simplify. Can you all simplify it? Do it faster. Find it out. Find out now. Just you have to integrate. E power minus 100r. Integrate. Start to. What is integration of e to the power of minus 100r? E power minus 100r divided by minus 100. Very good. Put the limits to simplify now. We getting the answer. Take it down. Do it faster. Let us take the answer. Fast. Just substitution of the values. Write again. Use the calculator and try to solve. Unless you solve, you don't get into it. So please try to solve, students. Answer, girls. Be fast, girls. No many answers will come from girls.
1.3 into 10 power minus 3.
1 point. No monkey. What is that? It is for e power minus 100 everything. It is 1.353 into 10 power minus 9. Sorry, minus 3. Here? 1.3 into minus. Minus sign is there. Minus 1.353 into 10 power minus 3. The answer is 2.326 into 10 power minus 2 amps. Check your answers. Others getting the answer? Yeah. 2.326 into 10 power minus 2 or it is 0.02.
0.02.
Correct. Clear, ma'am? Can you go to the next answer? Should I write on the board? Should I wait, students? Should I wait or shall we go to the next one? Next problem? Answer is taken out. 2.326. Those who have not got, please take it home. Current I is equal to 2.326 into 10 power minus 2 amps. Now what about the problem what I given in the last class? Did anybody solve that? I remember I gave a problem in the last class. Anybody has solved that? Very good. Good response. I am taking the problem and I am giving no one of the classes solved. So punishment I am going to give it as try to write the question 2 times tomorrow. That will be better, no? 2 times tomorrow. I will be checking. You have to bring your notebook tomorrow. You have class. I don't have class, but I will be checking your notebook. All are supposed to write the two times the problem. The next day you don't do it 3 times. We'll check like that. Then only you do. I gave a problem and I gave the answer also to check. Shakti Ben, you didn't do it. Why? I remember I given a problem. Is it not? I gave a problem in the last class. And what is the use of giving it? Tomorrow let me check that. I will be taking a note. I will be checking who all have done. I will give a mark there. The next day you don't do, you will be doing it thrice. Okay? We will have that. Then only you do the homework. Tomorrow all are bringing a notebook and coming to your class to check it. Okay? Even though you have the other class. Data structures, I will be checking your notebook. So try to bring it. If you don't bring also, you will be writing the next day 3 times. Okay, go to the next problem. Otherwise you will never learn. The current density, if the current density in the box bounded by, if the current density inside a box, if the current density inside a box is bounded by 5 planes, x is equal to 0, bounded by 5 planes, x is equal to 0, y is equal to 0, z is equal to 0, and 3x plus z is equal to 3, and 3x plus 3z is equal to 0. One more parameter is given, y is equal to 2. Take all these values, y is equal to 2 is also given. Right? 5 planes. Now what are the 5 planes? X is equal to 0, y is equal to 0, y is equal to 2, z is equal to 0, and the other is given by an equation. What is that? 3x plus z is equal to 0. Yes. J equal to is J equal to 3x ax vector plus y minus 3 ay vector plus z plus 3 into az vector. Ampere per meter. What is this? Current density. Now, again, find the total current. Flowing out. Find the total current flowing out of the surface of the box. Find the total current flowing out of the surface of the box. So the diagram is given. It is bounded by 5 planes, no? What is it? I have drawn the first 4 values. Listen once again. X is equal to 0 plane. Which plane? Which side it will be? It will be in y z plane. Correct? X is equal to 0 means y z plane. Y is equal to 0 means x is z plane. Z is equal to 0 means x y plane. One more parameter is given, y is equal to 2. Y is equal to 2 means again it will be in x z. It will be in x z. Y is equal to 2 now. 2 value now it will be like this. That is why this surface is taken as y is equal to 2. Clear now? Once again, present. We have to first mark the surface areas. So first y is equal to 0 means it will be in xz plane, right? If z is equal to 0 means it will be in the xy plane, and y is equal to 0 means it will be in the yz plane. One more value is given in your problem. What is that? Y is equal to 2, right? Y is equal to 2 means it is a constant value 2 here. So where it will be lying? Can you imagine? Like this it will be lying, right? It will be in z x plane. It will be in a z x plane. Can you all understand? Right. The next is you have to find one more area. As you are told x is equal to 0. When x is equal to 0 in this relation, what is z here? X is equal to 0 means what is z here? Z is equal to 3. So you have to mark z is equal to 3. Where will z is equal to 3 come? Where will z is equal to 3 come? Very good. It will be in the upper side, right? It will be in the upper side. So here z is equal to 3 plane will be coming. Can you all understand? Like this we have to first mark the planes and then we have to solve. Okay ma'am? Clear? Got it? Take it out. Draw the diagram, then we'll proceed. Simple. Again it will be very simple. What you have to find out? I is equal to j dot ds. Integrate all the limits. That's it. Okay? How many of you didn't understand z is equal to 3? How did I get z is equal to 3? How did I get z is equal to 3? When x is equal to 0, we have z is equal to 3. Z is equal to 3 means, can you imagine? Z from origin to z it is 3. So it will be lying in the upper part of your cuboidal surface. Can you all understand? Okay? Take it out. Now, we are going to find out the surface areas. When x is equal to 0, x is equal to 1, then y is equal to 0, y is equal to 2, z is equal to 0, and z is equal to 3. These values are given. X is equal to 0 is given, x is equal to y is equal to 0 is given, y is equal to 2 is given, z is equal to 3 is given, z is equal to 0 is given. Z is equal to x is equal to 1 is not given, no? How do I say x is equal to 1? Because when z is equal to 0 here, x will be equal to, when z is equal to 0, when z is equal to 0, 3x is equal to 3. So what is x? X will be 1. You all understand? So we are going to find out for all these, we are going to find out their surface areas. Okay, clear? Now,